So in this video we are going to see the next topic under integration. That's nothing but integration by paths. Okay, so this integration by paths, first of all we'll see what is this integration by paths. Under differentiation you had the product rule. Okay, so you were able to differentiate product of two functions. Now coming to integration, what did we have actually? We saw the substitution method, we saw, and after that by partial fractions. What in case if you have product of two functions like integration of sin x? If you have it like this, how will you integrate this one with respect to x? Substitution is also not possible, and also the product rule is not applicable here. So how is that you will do here? So here this is a basic formula, but for the working rule I will not be taking this formula anyhow. I'll just tell you here, if u and v are said to be two functions of x, then by the product rule you know d by dx of uv is equal to u into dv by dx plus v into du by dx you get. So here when you integrate it, d by dx of uv dx, integrating this, when you integrate this also plus integrate this also, what will happen here? You will only get it as uv, because here when you take the antiderivative of this, it's just uv you get here. Here in this case it's u dv plus v du. I cannot have it as uv because what is the integral you want here? Integral of x sin x dx. So what I will do here is, I'll just take here your u dv is what actually here, your u dv is equal to, taking it to the other side, this is kept as it is. When I take this to the other side, it's nothing but uv minus integral of v du. This is the basic formula you have here. Got it? This is the basic formula. So what I am going to do here is, I am going to take this as one as the first part and the other one as the second part. And how I have defined the formula in this case, you can just check out the formula here. So how I have defined here, suppose I have two functions here, f of x and g of x here. Okay, f of x and g of x. This is the first one and this is the second one. So how do I write my I equal to here? Your I is equal to first one into integral of second dx minus integral of d by dx of the first one into integral of second dx, the whole thing dx. Okay, so the whole thing comes under integration. Okay, when I do the problem you will understand it. Now here I have written as first, I have written it as second here. How do I choose this first and second? So for that I will be using the I late formula. Okay, so here what is this I late formula here? Actually here your I stands for inverse. Okay, I stands for inverse, L stands for logarithmic here, and your A stands for algebraic. Okay, so here A stands for algebraic, T stands for trigonometric. Okay, so here T stands for trigonometric, and E stands for exponential. Okay, so here E stands for exponential. This is what you have here. Okay, so based in this order only you will take your first and the second one. Now I told you integral of x into sin x, I told you here. Now don't think that this is first and this is second, not like that actually here. So you have algebraic, you have trigonometric. So see in this order which comes first. Algebraic comes first, trigonometric comes second. So what will I write here actually here? This is your first one and this is your second one. Now you will have to apply this formula. 1 into integral of 2 dx minus d by dx of I into integral of the first one into integral of the second one dx and dx. This is Roman letter 1 and Roman letter 2 here. You understood? Okay, so here maybe I can give you another example also here. So what is the other example I can give you? Suppose I have it as x into log x. So x into log x in this case, this is your algebraic and this is your logarithmic. So when you compare it, which comes first actually? This comes first and this comes second. So which one will I write here first? This one will be first and this one will be second. So this is the order I choose my first and the second one. Is the introduction part clear here? So instead of learning the formulas integral of u, dv, etc. here, just learn this one here. It will be easy for you to work out any problem. Okay, so with this formula in mind, we'll start with exercise 7.6. Integrate the functions. The first one is nothing but x into sin x. I already told you how will you choose your this one here, by using this I late method. So here if you see algebraic comes first and trigonometric comes second. So I have written it as 1 and 2 here. So what is your integral equal to? This is actually your integral. Don't confuse between these both. So here if you see, I am not taking it as u and all here. So you have written it as 1 and 2. You have it as 1 into integral of 2 dx. So we will see what we have written here. What is your 1? X into integral of sine x dx you have here. Okay. Minus integral of d by dx of 1. What will I get? D by dx of 1. What is your 1 here? It is x into integral of the second one. What is your second one you get here? Sin x dx. The whole thing is integrated with respect to x. Okay. Now what is integral of sin x? You get it as minus x cos x minus integral of d by dx is what? It's nothing but 1 into integral of sin x will give you what? Minus cos x dx. You understood? Now here you have it as minus x cos x. Minus into minus will give me what here? It's nothing but plus. So here if you see, it's nothing but plus sin x plus a constant. Is it clear to all of you here? So only formula you will have to remember this one. Again I am telling you what is it? The first one into the second integral with respect to x minus integral of, it's a big integral here, it's d by dx of the first one. You are only differentiating the first one into integrating the second one here, and this answer I will have to integrate it with respect to x. That is what I have written here. Got it? Yes. So here we'll start with the second question. X into sine 3x. So it's like the previous one. So which is your 1 here? This is your 1. This is your second one. What formula I am using here? It's the I late. By using I late I have taken here. Okay. So how will I write it here? It's okay. Your integral is equal to first. What's the first one you get here? X into integral of sine 3x dx you have here minus integral of d by dx of, what is your first one? It's nothing but x. Integral of, what will I get here? It's nothing but sine 3x, and the whole integrand you have it as dx. This is what you have here. You understood? Yes. So here when you integrate sine 3x, what will you get? It's nothing but minus cos 3x divided by the coefficient of x. I told you it is 3 minus integral of d by dx of x is what? It's nothing but 1 into integral of sine 3x will give you what? Minus cos 3x divided by 3 dx. Now what will happen? It is minus x cos 3x divided by 3. Minus minus will be nothing but plus integral of cos 3x. What is integral of cos 3x? It's nothing but sine 3x divided by 3 into 3. That's nothing but 9 plus a constant. Is it clear to all of you? Yes. Now here the same way we'll start with the third one. You have it as x squared into e power x. So I'll just take it as I equal to x squared into e power x. So by using this I late formula, what is our I late formula? What have you got here? By using this I late formula, what all you have actually here? You have algebraic and you have exponential. So which comes first? Algebraic comes first and exponential comes in the second one here. So in that order I have written it as 1 and 2. So once again a reminder, what's the formula? I into the first one into the second one, you will have to integrate it with this x minus d by dx of the first one, that is differentiation of the first one, okay, into what will I get here? Integration of the second one, the whole thing integrating with respect to x. This one will be done finally. Meanwhile I'll have to finish whatever is within the bracket. So we'll see how we have written here. I equal to the first one, what is it? It's x squared integral of e power x dx minus integral of d by dx of the first one. What's the first one here? It's x squared into integral of e power x dx, the whole thing dx here. So you will have it as x squared into, what is integral of e power x? It's nothing but e power x itself. It's x squared e power x minus integral of differentiation of x squared will give you what? 2x e power x dx. So I've just rewritten it as x squared e power x minus 2. I can take it outside. Integral of x into e power x. So again you have x into e power x in this case. So product of two functions. So how is that I'll have to do here? Again by using integration by parts I'll have to integrate it. So what will I do here? I'll take this as the first one and this as the second one. Again I'll be using the formula here. So what have you got? It's x squared e power x. Now here it is minus this 2, I have taken it outside. Okay, coming to the formula, x into, that's your first one, into integral of e power x into dx minus integral of d by dx of x. Okay, so differentiation of x into integral of e power x dx. This is what you have here. Okay, so how do I write here? It is x squared e power x minus 2 into x into what is integral of e power x? It's nothing but e power x minus what is differentiation of x here? It's nothing but 1 into integral of e power x. What is integral of e power x? It's nothing but e power x dx itself. Okay. So what will I have? X squared e power x minus, when you multiply it, it is 2x into e power x minus into minus, it's plus 2. What is integral of e power x here? It's nothing but e power x itself plus a constant. So what will I do here? I'll just take e power x common here. You're left with x squared minus 2x plus 2 plus a constant. This is what you have here. Okay. Yes. Now here the fourth one. Okay, so what's the fourth one you get here? X into log x you have here. So I've taken I is equal to x into log x. So again use the I late formula. So when I use the I late formula, so which one comes first here? Logarithmic comes first, algebraic comes second here. So I've written this as first and this as second. What's the formula? First into integral of 2 dx minus integral of d by dx of the first one, okay, into integral of the second one dx. Here again it is with respect to x. This is what you'll have to do here. Okay, so your I is equal to, what will you get here? Actually the first one. What's the first one you get here? It's log x into integral of the second one. What will I have here? It's nothing but x dx. This is what you have here. Okay, it is log x into integral of x dx you have minus, what will you get? It's integral of, you will have it as d by dx of, what will you get here? It's nothing but log x. This is what you have here, d by dx of log x into integral of the second one. What is the second one you get here? It's nothing but x dx with respect to x here. So it is log x into, what is integral of x here? It's nothing but x squared by 2 minus integral of, what is differentiation of log x? It's nothing but 1 by x into integrate this one, x squared by 2 dx. Remember, we have to integrate whatever you simplify it here. Okay, so what happens here? Your x and x, it gets cancelled here, x squared. You are left with x squared into log x by 2 minus integral of x by 2 dx you have here, which is equal to x squared into log x by 2 minus, what is integral of x? It's nothing but x squared by 4 plus a constant you have here. Okay, it is x squared by 4 plus a constant. So if you want, you can take x squared by 2 common and you're left with log x minus 1 by 2 plus a constant. Yes. Okay, so here the fifth one, you have it as I equal to integral of x into log 2x. So it's like the previous one only, but only thing is what you have, log 2x here. So I have taken this as the first one and this as the second one here. So you will get I is equal to the first one, log 2x into integral of x dx minus integral of d by dx of the first one. What is d by dx of the first one? d by dx of log 2x into integral of second one. I'll have to integrate it. So what is the second one? It's x dx with respect to x. So what will I have? Log 2x into integral of x. What will you get? It's x squared by 2 minus integral of differentiation of log 2x. What is differentiation of log 2x? 1 by 2x into 2. What will you do here? I am applying the chain rule here. Into, what is integral of this? It's nothing but x squared by 2 dx. So here if you see, your 2 and 2 gets cancelled. Your x and this x squared, that also gets cancelled. So you're left with x squared by 2 into log 2x minus, what happens here? I'll just take this 1 by 2 outside into integral of x dx, which is equal to x squared by 2 log 2x minus x squared by 4 plus a constant. Is it clear? Yes. Now here we'll start with the sixth one. Again you have it as x squared into log x. So I equal to x squared into log x. I think you will not have any doubt in choosing your first one and the second one. First comes log, second comes your algebraic one here. So if you want, I'll just write the formula again here. The first one into the second one, you're integrating with respect to x minus integral of differentiation of the first one you get here, okay, and into integration of the second one here, okay. So sorry, yeah, into second one into the differentiation of this, the whole thing, what is that you will have here? It's nothing but dx. So how do I write here? First one is log x into integral of, what will I get here? X square dx minus integral of d by dx of the first one. What is d by dx of the first one? It's nothing but d by dx of log x you have here into integral of the second one. What is integral of the second one here? It is x square dx. The whole thing you write it as dx. You understood? So it is log x into integral of x squared. What will you get? It's x cube by 3 minus differentiation of log x. What will I have? It's 1 by x into, what is integral of this one? It's nothing but x cube by 3 dx is what you have here. So here again it gets cancelled. So you are left with x cube by 3 log x minus integral of x squared divided by 3 dx. So I can write it as x cube by 3 log x minus, here when you integrate it, you will get it as x cube divided by 9 plus a constant. Is it clear? Okay. Now we'll start with the seventh question here. So what's the seventh question you get here? X into sine inverse of x here. So what is it? When I read itself, you will know what is that I mean by saying sine inverse. This stands for inverse. So which comes algebraic here? Inverse comes first and the algebraic one, it comes second. So what will I do here? I will just take this as 1 and this will be taken as 2 here. Okay, so again I'll be using the formula 1 into integral of 2 dx minus integral of d by dx of 1 you have here, okay, into integral of second one dx. Here again you have it as dx. This is what you have here. So I can write this as I equal to, what will I get here? 1. What is your 1 here? It's nothing but sine inverse of x into integral of the second one. What will I get? X dx minus integral of d by dx of the first one. What's the first one you get here? Sine inverse of x into integral of the second one. What is integral of the second one here? X dx, the whole thing dx. So you will have it as sine inverse of x into integral of x is what? X squared by 2 minus integral of, what is differentiation of sine inverse of x? It's 1 by square root of 1 minus x squared into x squared by 2 dx. So how is that you have here? It is x squared by 2 sine inverse of x. We have taken this minus 1 by 2 outside. It's integral of x squared by root of 1 minus x squared. Yes. So this part not a problem. This one I'll have to integrate it. So when you see here, I cannot use the method of substitution because here also you have x squared, here also you have x squared. So that part is not applicable here. So what I'm going to do here is, I'm going to add and subtract 1 and then bring this. So I'll just bring this minus sign inside and see what we do in the next step here. So you have it as x squared by 2 into sine inverse of x. So this minus 1 I have minus sign, I brought it inside. So you will have it as minus x squared. I've added and subtracted 1 here. So you will have it as 1 and minus 1 divided by square root of 1 minus x squared dx. So you have it as x squared by 2 into sine inverse of x plus 1 by 2 into, we'll just split it as 2 parts. 1 minus x squared divided by square root of 1 minus x squared dx. Here again it's plus 1 by 2 into integral of minus 1 divided by square root of 1 minus x squared dx. So what will I get here? This is equal to x squared by 2 into sine inverse of x plus 1 by 2 into integral of, okay, when you rationalize this, you will get it as square root of 1 minus x squared dx you will have here. Plus into minus is what? Minus 1 by 2 square root of 1 by square root of 1 minus x squared. So both the places I will be using formulas. Here this formula I wouldn't have told you so far actually here. So this is the formula you have here, okay, that is your integral of square root of a squared minus x squared is equal to x by 2 into square root of a squared minus x squared plus a squared by 2 into, what will I get here? Sine inverse of x by a. This is what you have here. This is the formula you get. So it is x squared by 2 sine inverse of x plus 1 by 2 into, what will I get? x by 2 into square root of 1 minus x squared plus a squared. What is a squared? 1 by 2 into sine inverse of x you have here. Okay, close a bracket. Now minus 1 by 2 into, what is this? Integral of 1 by square root of 1 minus x squared. What is it equal to? Minus 1 by 2 into, it's nothing but sine inverse of x plus a constant. You know what is differentiation of sine inverse of x here? So what is differentiation of sine inverse of x? It is equal to 1 by square root of 1 minus x squared. So what is the integral of 1 by square root of 1 minus x squared? You will get it to be equal to sine inverse of x. Now we will just simplify it here. It is x squared by 2 sine inverse of x. When you multiply it, you will have it as x by 4 square root of 1 minus x squared. When you multiply this, you will have it as 1 by 4 into sine inverse of x. Here it's nothing but minus 1 by 2 into sine inverse of x plus a constant. So this term I have written here, this also you have written. You can just subtract these both. When I subtract it, when you take the LCM, you will have it as 4. So you will have it as 1 minus 2. That's nothing but minus 1 by 4 sine inverse of x plus a constant. Clear? Only the integration is slightly different here, that's all. Okay. Now we'll start with the 8th one. What is your 8th one here? Integral of x tan inverse of x. Again the same method. What is it here? By I late. So which comes first here? Your inverse comes first and your algebraic comes second here. So it is 1 and 2. So I think I need not write the formula hereafter. You can remember it. So what will I get here? First one, tan inverse of x into integral of the second one, it's x dx, minus integral of d by dx of the first one. What's the first one you get here? Tan inverse of x into integral of the second one. What will you get here? It's x dx, the whole thing with respect to x. Okay. So what will I get here? It's tan inverse of x into integral of x is what? X squared by 2 minus integral of differentiation of tan inverse of x. What is differentiation of tan inverse of x? 1 by 1 plus x squared into integral of x. What will I get here? It's nothing but x squared by 2 dx. This is what you have here. Okay. So I have written it as x squared by 2 into tan inverse of x minus 1 by 2 into 1 by this 2 I have taken it outside. You are left with x squared by 1 plus x squared dx. Now as I told you earlier, by the method of substitution it is not possible here. So what I am going to do here is I am going to add and subtract one like the previous one here. Okay, so we will see what you get. Okay, so it is x squared by 2 into tan inverse of x minus 1 by 2 integral of adding and subtracting 1. 1 plus x squared minus 1 divided by 1 plus x squared dx you get here. So x squared by 2 into tan inverse of x. So here when you segregate it, this is what you get here. 1 plus x squared divided by 1 plus x squared minus 1 divided by 1 plus x squared. So what will you get? Minus 1 by 2 into integral of 1 plus x squared by 1 plus x squared dx you get here. Minus into minus will be nothing but plus. So it's plus 1 by 2 integral of 1 by 1 plus x squared dx you get. So here it is x squared by 2 tan inverse of x. It gets cancelled here. It's minus 1 by 2 integral of dx. What is this formula here? It's nothing but tan inverse of x, because you know what is differentiation of tan inverse of x here? Differentiation of tan inverse of x is equal to 1 by 1 plus x squared. So what is integral of 1 by 1 plus x squared? That's nothing but equal to tan inverse of x here. Got it? So what's the formula you get? Sorry, the answer, it's x squared by 2 tan inverse of x minus x by 2 plus 1 by 2 into tan inverse of x plus a constant. So here the 10th question, it's sine inverse of x the whole square. Until now if you saw, you had product of two functions you had actually here. Okay, so here it's not like that. You have I equal to integral of sine inverse of x the whole square. It's not possible for us to keep it integrated as it is. It's not like differentiation here. So what I have done here is I have written it as sine inverse of x the whole squared into 1 dx. Can I write it like this? So whatever it is, it's just a constant here. But anyhow, this inverse will be taken as a first one and this will be nothing but your second one. That's your dx along with this dx. So here, according to the formula, I can write it as sine inverse of x the whole squared into integral of, what will you get here? It's nothing but dx minus integral of d by dx of what will I get here, sine inverse of x the whole squared, because d by dx of the first one, what's the first one, sine inverse of x the whole squared, into integral of the second one, what's the second one here, 1 dx. So here 1 with respect to x, that's why I'm telling it as 1 dx here, it's nothing but dx, the whole thing with respect to x itself. So it is sine inverse of x the whole squared into integral of dx. What is integral of dx? It's nothing but x minus integral of differentiation of sine inverse of x the whole squared. What is differentiation of this one here? It is 2 into sine inverse of x into differentiation of sine inverse of x. What will you get? It's 1 by square root of 1 minus x squared into integral of dx. What will I have here? It's nothing but x dx. Okay, see how I put the bracket here. I hope you're able to understand this one. First I'm differentiating this. When I differentiate it, it's 2 into sine inverse of x into differentiation of sine inverse of x, the chain rule. 1 by square root of 1 minus x squared into integrating this, it's x dx. Got it? So here we have it as x into sine inverse of x the whole squared, minus 2 will be taken outside. You will have it as x sine inverse of x divided by square root of 1 minus x squared. Yes? Now the problem again arises with integrating this one. So here if I didn't have this x, not an issue for me at all. I can very easily integrate it with respect to by substitution method. But I have a x there, and by parts also I don't have only two functions, I have three. X sine inverse of x, 1 by square root of 1 minus x acquired. So I cannot do it even by parts. So what we'll do here is we'll try it to bring it to solving it by parts here, integration by parts. So what's the substitution I put here? Put t is equal to sine inverse of x. So what will I get? dt by dx is equal to 1 by square root of 1 minus x squared. You will have dx is equal to dt into square root of 1 minus x squared. Okay, done with this. So your I is equal to, the first one I can keep it as it is, x into sine inverse of x the whole squared minus 2 into integral of, what will I get here? It is x, and here your sine inverse of x is nothing but t divided by square root of 1 minus x squared. What is your dx equal to? dt into square root of 1 minus x squared. So here if you see, it gets cancelled here. Okay, so it is x into sine inverse of x the whole squared is what you have here, minus 2 into, now what is your x here? From this substitution, can I write x is equal to sine t? Yes, when it goes to the other side, you will have it as sine t. So see, what have I written here? Sine t into t. So have I brought it to a position where you can integrate it by parts actually here? Have you understood? This is by the method of substitution. I have just brought it to a part where you can integrate it. That's all. So how do you integrate it? T into sine t. So you know this is algebraic. This is nothing but trigonometric. So you will have it as 1 and 2. So here it is x into sine inverse of x the whole squared is what you have here. Okay, x into sine inverse of x the whole squared minus, what will I get? 2 into integral of, okay, come. First one, that's t into integral of sine t minus integral of d by dt of, what will I get here? The first one. What is d by dt of the first one? It's t. Integral of the second one, it is sine t dt with respect to dt. Whatever I have done with respect to x, I have done it with respect to t. That's all. Okay, so here that is what you have here. Got it? So here it is x into sine inverse of x the whole squared minus 2 into integral of, what is integral of sine t? It's minus t cos t. Okay, now here coming over to the next one. Here d by dt of t. What is d by dt of t? It's nothing but 1 into, what is integral of sine t? It's minus cos t you will get. You already have a minus sign here. So minus of minus, it will be nothing but plus. Now x into sine inverse of x the whole squared, minus into minus is nothing but plus. So it's plus 2t cos t, plus into minus is nothing but here minus 2 into integral of cos t. What is integral of cos t? That's nothing but sine t plus a constant. Got it? So how do I write here? X into sine inverse of x the whole squared plus, now substitute the value of t. What is your t here? 2 into sine inverse of x cos of sine inverse of x minus 2 into sine of sine inverse of x plus a constant. Is it clear to all of you here? Okay, just do it minutely and patiently. You will be able to understand this one here by parts. Okay, another important one.